In this video, I'll be going over the Chapter 5 homework. So in this first example, we're going to be looking at how much you can borrow. So a few years ago, Simon Powell purchased a home for $110,000. Today, the home is worth $150,000. His remaining mortgage balance is $50,000. Assuming that Simon can borrow up to 80% of the market value, what is the maximum amount he can currently borrow against his home? So here's the formula for the amount available for borrowing. We're going to take the maximum loan percent and multiply it by the current market value, and then take that value and subtract it by the current loan. So we're going to take the 80% or 0.8 in decimal format, multiply it by the 150K, and then we'll go ahead and simplify that. That'll give us 120,000. Then we'll go ahead and subtract the current loan. And when we subtract the two numbers, we get $70,000 available for borrowing. In this next example, we're going to be analyzing living within your means. So Louise McIntyre's monthly gross income is $2,000. Her employer withholds $400 in federal, state, and local income taxes and $160 in Social Security taxes per month. Louise contributes $80 per month for her IRA, which is a retirement account, and her monthly credit payments for Visa and MasterCard are $35 and $30 respectively. Her monthly payment on an auto loan is $285. So we have a couple of formulas here that we're going to be working with. First, we need to find the net income. So this is where we'll take Louise's gross income, subtract any taxes, and subtract any retirement contributions. So our gross income stated above was the $2,000. The taxes, which were federal, state, and local, was $400. The Social Security was $160, and then her IRA contribution was the $80. So plugging all that into our calculator, we get a net income of $1,360. In other words, the net income is our take-home pay. This is how much goes into her checking account that she can use for other things, such as paying off debts. So next we have to calculate the monthly debt payments. So we're just going to add up all of our debts. That's the Visa credit card, MasterCard credit card, and her car loan or auto loan. So when we add the 35, 30, and 285 up, we get a monthly debt payments of $350. Now, it's important to also understand what your debt payments to income ratio is. And so what we'll actually do is take our total debt payments that we calculated above and divide it by our after-tax income. And you'll notice that the language is not always exactly the same. Net income, after-tax income, take-home pay, they all mean the same thing. So it's really important that we understand the language and concepts and not expect it to be exactly the same. So when you talk to different people, they may call it different things. So taking our 350 divided by the 1360, we get a debt payments to income ratio of 0.2573 in our calculator, but we know in decimal format we can convert it into a percent, so that'll be moving our decimal over two places, and that equates to 25.73%. Now recall in the textbook that experts suggest that you spend no more than 20% of your net income on consumer credit payments, because other aspects of your income need to go to other things like rent and food. So we can see that her debt payments to income ratio is higher than the recommended 20%. That means she is not living within her means. In this next example, we're going to be looking at the debt to equity ratio. Robert Sampson owns a $140,000 townhouse and still has an unpaid mortgage of $110,000. In addition to his mortgage, he has the following liabilities. Now again, we have to understand the different concepts and vocabulary from the different chapters, so we know that liabilities is something we owe to someone else. So we have some credit card related liabilities as well as a couple of loans. So Robert's net worth, not including his home, is about $21,000. So this is given to you in the problem. This equity is in mutual funds, an automobile, a coin collection, furniture, and other personal property. So they're giving you a little bit of background around that $21,000. So what is Robert's debt to equity ratio? Has he reached the upper limit of debt obligations? You'll want to explain. So here's the formula for our debt to equity ratio. We're going to take our total debt excluding mortgage. So we do not count the mortgage in our debt. And then we'll divide it by our net worth excluding the home. Again, we don't include the home as part of this ratio. So we're going to take up all of our debts here, add them all up, and then put that in parentheses because they're a grouping, and then we'll divide that by the net worth of 21,000 that was given to us. And we get 0.35, or if I move the decimal over 2 places, that equates to 35%. So what does this mean? Recall that the upper limit of the debt to equity ratio is 1. So as long as our ratio is not equal to 1 or 100%, then you've not reached your upper limit. In this next example, we're going to be looking at debt payments to income ratio. Madeline Rollins is trying to decide whether she can afford a loan she needs in order to go to chiropractic school. She lives at home and works in a shoe store, earning a gross income of $820 per month. Her employer deducts a total of $145 for taxes from her monthly pay. Madeline also pays $95 on several credit card debts each month. The loan she needs for school will cost $120 per month. Help Madeline make her decision by calculating her debt payments to income ratio with and without the college loan. So we're going to be using this formula here twice for both scenarios. And then I put a little reminder here that you'll be applying the 20% rule to see if she can afford chiropractic school or not. So first, let's calculate her ratio if she goes to school. So in our formula, we're going to add up all our debt payments and divide it by our net take-home pay. So here's my numbers. The $95 is the credit card debts. The $120 is the school loan. And then we'll divide that by the net take-home pay. Again, our net take-home pay is our gross minus any taxes. So our gross was the $820, and the taxes that her employer deducts is the $145. So you'll notice the parentheses because order of operations matter. So when I add these two numbers up and subtract these two numbers and then divide, we get 0.3185 or 31.85%. Let's now calculate the debt payments to income ratio without school. And so without school, her debt payments from the credit cards was the $95, and we'll divide it by the net take-home pay. So it's the same math in the denominator here as above. Again, the only difference here is there's no loan for school. So when I, again, subtract these two numbers and then divide 95 by the net take-home pay, we get 0.1407, or moving my decimals over, I get 14.07%. So we can see in this scenario that Madeline's debt payments to income ratio is good without school because it's under the 20%. However, to add school loans in and to go back to school, she'd be over that 20% rule. So she can't really afford the school loan right now. So in this next example, we're going to be looking at annual percentage rates, or APR. Joshua borrowed $500 on January 1st, 2017, and paid $50 in interest. The bank charged him a service charge of $5. He paid it all back at once on December 31st, 2017. So the dates are important so that we can see this was throughout an entire year, and we're going to be calculating the APR. So we need two formulas here that we're working with, and the first thing is we want to identify the finance charge. So we'll be adding our interest and the service charge. So the interest was given to us at $50, and the service charge was mentioned to be $5. So when I add these two up, we get a finance charge of $55. Now to find the APR, we'll go ahead and take the finance charge we just calculated and divide it by the principal. Remember, the definition of the principal is what you originally borrowed. And so we'll take the $55 divided by the $500, and that'll give us an APR of 0.11 or 11%. In this next example, we're going to be looking at cash advances. Sydney took a $200 cash advance by using checks linked to her credit card account. The bank charges a 2% cash advance fee on the amount borrowed and offers no grace period on cash advances. Sydney paid the balance in full when the bill arrived. What was the cash advance fee? What was the interest for 1 month at an 18% APR? We're going to answer these two questions first, and then we'll answer the remaining two questions on the next slide. But to answer the first two, we've got these two formulas here. So for the cash advance fee, we're going to use the cash advance fee percentage and multiply it by how much we borrowed. So we'll take the 2% fee times the $200 cash advance she pulled out, and that'll give us a fee of $4. Now for the monthly interest, we'll go ahead and take the annual rate that was given to us at the 18% and divide it by 12 because there are 12 months in a year, and then go ahead and multiply it by the cash advance amount. So taking our 18% or 0.18, divide by 12, then multiply by 200, we get a monthly interest of $3. Now, in the next part of the problem, it asks what was the total amount she paid? What if she had made the purchase with her credit card and paid off her bill in full promptly rather than waiting? So here's our two formulas. For the total amount paid, we'll be using the values we previously found on the last slide. So the cash advance fee plus the monthly interest plus the cash advance amount. So that's the $4, the $3, and the $200 from our scenario. And that gives us a total amount paid by Sydney as $207. Now for this next part, in this last formula, the total amount paid if she had paid off her bill in full promptly is simply the cash advance amount, meaning she's not incurring the fee or the monthly interest because she paid it off right away. In this next example, we're going to be looking at simple annual interest cost. So what are the interest costs and the total amount due on a 6-month loan of $1,500 at 13.2% simple annual interest? So our two formulas here, we're going to first find the interest cost, and then we'll figure out the total amount due. So our interest cost formula is where we take the principal times the rate times the time in years. So we'll go ahead and take our principal of the $1,500. Here's our rate of 13.2% or 0.132 in decimal format. And then remember that the time has to be in years because, again, we're looking at annual interest. So because we were doing 6 months, we'll take the 6 months divided by 12 months. So we know that's half a year. So you have to do a little bit of conversion to make sure you're in the correct units of measure. In this case, it's got to be years. And then you can plug all this into your calculator. And so our interest cost will be $99. Now for the total amount due, we'll go ahead and take the interest we just calculated and add it to our principal. So we'll take the $99 plus the $1,500, and so the total amount due is $1,599. In this next example, we're going to be looking at auto loans. So after visiting several car dealerships, Richard selects the car he wants. He likes its $10,000 price, but financing through the dealer is no bargain. Richard has $2,000 cash for a down payment, so he needs an $8,000 loan. In shopping at several banks for an installment loan, he learns that interest on most auto loans is quoted at add-on rates. That is, during the life of the loan, interest is paid on the full amount borrowed, even though a portion of the principal has been paid back. Richard borrows $8,000 for a period of 4 years at an add-on interest rate of 11%. So again, when you're getting an auto loan, you really want to understand the terms of how interest is charged and what you're responsible for, because some situations have better terms than others. So in part A, we're going to find out what is the total interest on Richard's loan. So this should look familiar. We just did it on the last slide. Here's our interest cost, abbreviated I. That's our principal times the rate times the time in years. So we'll take the principal, but remember we're doing a down payment of $2,000. So we'll take the $10,000 minus $2,000 because we're going to be borrowing or getting a loan of $8,000. Then our rate is the 11% or 0.11, and the time in years is the 4 years in our story. So when I plug all this into my calculator, and again, make sure to work in the parentheses first before you work with the rest, our interest cost is $3,520. So in part B, we now want to find out what the total cost of the car is. And so that's going to be your down payment, your interest, and the principal. So this is the total cost. When I put my numbers, the $2,000, the interest we found above, and the principal, or what we borrowed, our total cost for the car is $13,520. So even though our car price was $10,000, we can see once we account for interest, that car actually costs $13,520. In part C, so we're still on the same problem, we need to find out what the monthly payment will be. So for the monthly payment, here's our formula. We'll take the interest plus the principal and then divide that amount by the number of months. So we're adding up our costs and spreading it out over the months. So our interest that we previously found in part A was the $3,520, and the principal being borrowed is the $8,000. When we add those two numbers up, we'll go ahead and divide it by 48 months because there are 12 months in a year and we have a loan for 4 years, so 12 times 4 is 48 months. So when I go ahead and plug this into my calculator, we get a monthly payment of $240. In Part D, we want to know what the annual percentage rate or the APR is. So here's our formula. So if you need help with the abbreviations, under the Chapter 5 Homework Formulas and Files page, I do have the abbreviations explained. So our formula in the numerator up here, it's 2 times lowercase n, which is the number of payment periods in 1 year, times I, which is the interest, and then we'll divide it by the denominator. In our denominator, we're working with a big N, which is the total number of payments to pay off the loan in entirety. So all of the payments. Plus 1, that's just the way the formula is set up. Then multiply that by our P, which is the principal, and then take that value, and that'll be what you divide the numerator by. So we'll go ahead and plug in our numbers. There's my 2, my 12, because there's going to be 12 monthly payments in 1 year. The interest we calculated earlier, which is the $3,520, and then divided by our principal loan of $8,000 borrowed, and then our big N, which is the 48 months, plus 1. So when I simplify, solving at the top and solving the bottom, I'll get $84,480 for the numerator, and I get $392,000 in the denominator. And then when I divide these two numbers, we get an APR of 21.55%. That's pretty high. But this is how we would calculate the APR to really understand what we're paying. So if you have any questions, just let me know.